Today you're going to be checking solutions to equations. So you're going to be given a table like this and an equation. Your job is to figure out is which one of these are solutions, if there are any. So I'm going to walk you through two examples where one is a solution and one is not a solution, so you can see what they both look like. Your first step is going to be to copy the equation, so I'm going to write it down. And this is the algebraic way to check for solutions. So we're checking this algebraically, so write down the equation. We're going to evaluate the first one. So I'm going to take my first y value, -5. Where there's a y, you're going to replace that with -5. You can notice here that I replaced y with -5, and I also put it in parentheses. So make sure you have parentheses around your value. And what you're going to do is to simply use the order of operations. So all the work is going to occur here because you can see this equals -26. There's nothing to do on the right side. That stays the same. We're just going to use order of operations over here where we have subtraction and multiplication. Don't forget your PEMDAS. Remember, PEMDAS is parentheses, exponents, multiply, divide, add or subtract in this order. So looking here, I have subtraction and multiplication, so I'm going to multiply first. Here I have 2 minus, when I multiply 4 times -5, I get -20, and then 2 minus -20 is going to be 22, equals -26. 22 is equal to -26 is false. Now remember, I replaced y with -5, and again, I got that from my table. I checked -5, I swapped it out with the y, and when I evaluated this using order of operations, I got 22 as -26, which is not the same. They are not equal to each other. That means this number that I just checked is not a solution. So when I go to my table, -5, is it a solution? No, and then I would choose that as my answer for -5. It's not a solution. Now I'm going to show you what it looks like when a number is a solution. So we're going to check 7 because I already know 7 is my solution. So first thing you're going to do to show this algebraically is you're going to write the equation down on your paper. And what I recommend is doing like what I did here. Put parentheses around the variable that you're going to replace. And in this case, I'm going to replace y with 7. So my y is now a 7 here. And I'm going to use my order of operations to simplify this. And the good thing about these tables is that once you do one, the steps are going to be the same thing. It's just going to be different calculations for your answers. And here you can see that 2 minus, so if I multiply this, I get 28. And notice that's a little bit different from this one because here I multiply 4 times -5 and I got -20. Here it's just 4 times 7, which is 28. And I can see 2 minus 28 is -26. Bring down my equal sign, and I bring this down. And again, it's important to notice that this does not change. All the work is happening over here. This, you just got to keep bringing it down to the next step because we're just trying to see when we simplify all this, if we end up with the same answer as on the other side. So -26 equals -26. That is actually true. They are equal to each other. And that lets me know that the value I checked when I replaced y with 7, that 7 is a solution because when I substituted it and evaluated it, I got the same answer on both sides. So remember, we've been working with equations, and an equation, we're looking for what balances the equation. You end up with the same thing on both sides. So it should be balanced. In this case, it is balanced. Therefore, 7 is my solution. So I go to my table, and I will choose yes. Yes, 7, it is a solution, right? And that's your final answer. Then your second type of problem you're going to work with today is inequalities. Inequalities is the same exact idea as with the equations. You're going to take the numbers, substitute it, and check if it is true or false. If it is true, you would put yes, it's a solution. If it's false, you would put no, it's not a solution. In this example, I'm also going to show you one of them where it's true and one of them where it's false. Where, in other words, when one is a solution, when it's not a solution, so you can see the differences. But notice that we are working with inequalities, so you have to recall what these each mean. So as a quick reminder, this means greater than when you read it. This means less than, greater than or equal to, and less than or equal to. So step 1, when you're checking it algebraically, copy the inequality. In the next step, I'm going to replace y with the number I'm evaluating. So I'm going to check when y is 11 and see if that's a solution or not. So you can see here, I replaced y with 11. And now, only one thing I have to do here is just add these two and check if it's true or false. So since all I had to do was add 34 plus 11, I get 45. And I read this, 44 is greater than 45. 44 is greater than 45 is actually false. So if that is false, that means this number that I just evaluated, this value that I just put in place of y, is not a solution. So 11 is not a solution. So I'd go over here to my table, 11, is it a solution? No. Then the second number I'm checking is when y is 5. So I replace y with 5. Now all I have to do is add these two. 34 plus 5 is 39. Notice on the left there's nothing to do. It's a single number, so we just keep bringing it down. And when I read this, it says 44 is greater than 39. Remember, that means bigger. And then you just ask yourself, is 44 bigger than 39? Yes, it is. So that is true. And what that lets me know is the number that I just evaluated, this value here, 5, is a solution. So I go back to my table. 5, is it a solution? I would put yes. And then your last problem set for today is going to be in IXL. So you're going to be looking at nonlinear equations, which means they're not straight lines, and systems of equations. This will be like more of a bonus here. But the good thing about these two problems is you're going to be using DESMOS, which you're allowed to use on the PSAT. So I'm going to show you how to check for solutions looking at it without writing any steps down. We're going to just use the graphing calculator in DESMOS. So the questions you're going to get is something like this. Is 3-2 a solution to this equation? So the first thing you want to do is you're going to type this equation into DESMOS in this line over here. So you can see here I started typing in my equation. Now notice they want you to type in 6x squared, so an exponent. So the way you do that is when you get to that part, you're going to go down here. There's like a little calculator icon. So I'm going to open up the calculator where it says this a squared. Click on that, and that's going to give you a squared button there. And then I'm going to go back, and it says to put in plus negative 4x. So I put plus negative 4x, and you'll see your graph will pop up here. Next, you want to check, is this point a solution? A solution, when we're looking at a graph, it just means one thing, that when you plot this point, it'll be on that line. So let's see how to plot the point. So I'm going to go to the next line. I'll put a parenthesis, 3, 2, close the parenthesis, and by doing that, you'll see a point pops up here. And I'm going to put the label here so I can see where my point is. So I click label. So you can see here, 3, 2 is right here. And all you got to do is ask yourself, is this point on the line or off the line? Right, here's my line. This is not on the line. Therefore, this is not a solution. So this is the graphing way to check if your point is a solution or not. So it's not on the line. It's not a solution. So I'm just plotting another point, the point 0, 0. I'm going to click on label, and you can see here 0, 0 is here. You can see the red point. It's on the line. Therefore, this is a solution. So as long as your point is on the line, doesn't matter where, as long as it's on the line, it's a solution. If it's not on the line, it's not a solution. And that's what you're going to do for each of these exercises, is you're going to use DESMOS to answer these questions. And you might get the question, like it might vary. Does this point satisfy the equation? Same question, you just want to know, is it a solution? So you're going to put this into DESMOS, plot the point, and check if it's on the line or off the line. Then I'm just going to do one more example so you can see here. We have an exponent of a 3. So in DESMOS, to do that, when you put 4x, if I want to put a 3 for my exponent, I'm not going to click on the a squared. I'm going to click on AB. And by doing that, it allows you to put whatever number you want in place. So I'm going to put a 3 there. And then notice that it's still clicking on the exponent. So I'm going to hit the right arrow key. So that way I'm back to typing in my regular numbers. So you can see here that this is my next question here. I typed it in. I put the point 0, negative 1. And then when I see here my graph, here's my line. And you can see 0, negative 1 is not on the line. Therefore, I know it's not a solution. So I'd go here. No, it does not satisfy the equation. Submit it, and I can see it's correct. And then the last question type you're going to get is they want to know if the point's a solution to the system. So a system of equations just means you're going to end up with more than one equation. Notice here we have 2. So you can have 2, 3, 4, 5, doesn't matter. A system will always have more than one line. So same idea though. You're going to put these two equations into DESMOS, plot that point. And the only difference here is to be a solution to a system, this point has to be on both lines at the same time. So you can see here, I put my point, my two equations, and you'll notice that these two lines are not showing you where they cross paths, because your solution is going to be where they intersect, where do they meet. So all you got to do is take your cursor, click and hold, and then drag it down so you can see where they meet. And you can see here that they meet at this point here. So if I were to put the point 210, I'm going to click label, and you can see that this is the point 210. And since this point is on both lines, in other words, where they both cross, this is a solution because it's on both lines at the same time. So to be on both lines at the same time, it is going to be occurring at the intersection point. Wherever they cross paths will be your solution. So 210, yes, it is a solution to the system, again, because it's on both lines at the same time. And I'm just plotting one more point here, 0.8, so you can see the difference. So notice 0.8 is on the black line. So this is a solution to this equation. But notice this point is not on this line. Therefore, it's not a solution to the system. Because remember, a system is more than one line, and to be a solution to a system, it has to be just like this point here. It has to be on both lines at the same time. So notice here, it is a solution here, but it's not a solution to the system because it's not on both lines. So be careful with questions like that.